Hello students, welcome to the next video of measures of dispersion. In today's video we are going to see example of range and the next measure of dispersion, which is mean deviation. So, first of all, we are having three types of data, right? You remember the types of data? We have discussed about that. So, we are having three types of data. First one is ungrouped, second one is group discrete, and the third one is group continuous data. Now, all these measures of dispersion, we have to find the measure of dispersion for all these three types of data. So there is a slightly different formula for all types of or different types of data. So now first we will see the range for ungrouped data. Okay, now ungrouped data means only numbers are given, right? Only discrete values are given. Now as you can see here, only discrete value is given. So our range is maximum value minus minimum value, okay, or highest value minus lowest value. So highest value in this is 35 and the lowest value in this is 6. So range is 35 minus 6, that means 29. Then coefficient of range is range upon L1 plus L2. Okay, you can denote range, coefficient of range by any letter. Previously I had denoted this range as range is equal to H minus L, right? Now I am writing range as L1 minus L2. Okay, you can denote range, coefficient of range by any letter. So here coefficient of range will be range upon L1 plus L2. That means L1 minus L2 upon L1 plus L2. This is the formula for coefficient of range. Now we have to substitute the value. So 35 minus 6 upon 35 plus 6. Okay, so we'll get 29 upon 41. Clear? So if the data is ungrouped data, means only discrete values are given, then simply we have to find the highest value and we have to find the lowest value, and then range will be highest value minus lowest value, and coefficient of range will be highest value minus lowest value upon highest value plus lowest value. Okay, now let us see the range for group discrete data. Now first we have to identify this data, right? Question is find the range and coefficient of range of the following distribution. What is given? X values are given and frequency given. So since frequency is given, therefore this is a group data. Okay, now X values. See, the X values are different numbers, right? X values are different. That's why this is a discrete. X values are discrete, and hence this type of data is known as a group discrete data. Okay. Now for group discrete data, range will be find the highest value of X. Okay, we are not going to use this frequency. This frequency is useless in range. In range we are not interested in frequency. Okay, so make a note that we are not using this frequency. We are only interested in X values. So we'll take largest value of X, which is 50. Okay, then we will take the smallest value of X, and that is 10. Clear? From X values only we will get the largest value and smallest value. There is no use of frequency. So for range, frequency is useless. We are not using this frequency. It is just show part. Okay. So here largest value of x is 50 and smallest value of x is 10. And hence range is equal to L minus S, largest minus smallest. So that is equal to 50 minus 10. So that is equal to 40. And coefficient of range will be L minus S upon L plus S. So 40 upon 60. So that is equal to 2 upon 3 means 0.67. Okay. Once again, if frequency is given, then it is a group data. Okay. Then check the x values. Since the x values are discrete or different, therefore it is a group discrete data. Now for range, we are not using this frequency. We are only going to use x values. So from x values, find the maximum or largest value and find the smallest value. So range is largest minus smallest. So 50 minus 10, 40. And coefficient of range is L minus S upon L plus S. So that is equal to 0.67. Okay. Then now we are going to see range for group continuous data. Okay. Now again the question is find the range and coefficient of range of the following data. Data is age in years. Age is given in interval. So 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69 and 70 to 79. And corresponding frequency is given as 361, 223, 137, 53, 19 and 4. Okay. Now we are interested in range and coefficient of range. So first thing, data identification. Okay. Now frequency is given. That means data is a group data. Right. Now class interval is given. Therefore data is a continuous data. So this data belongs to group continuous type of data. Right. Now for this type of data, first thing, just check this class intervals. Okay. Check the two consecutive class intervals. Here class interval is 10 to 19 and here it is 20 to 29. Right. So it is a break. It is not continuous. It is a break. There is a break. Right. From first to second there is a break. It ends at 19 and it will start from the 20. Then what about 19.4, 19.8? Right? All these values are missing. So in that case, first we have to make this class intervals in the form of exclusive. Okay, this is exclusive. So from exclusive, we have to make it inclusive type of class intervals. Inclusive means continuous. So for that, what I am going to do, I am going to subtract 0.5. Okay, from the lower value. Okay, lower value of class intervals. In that we are subtracting 0.5. We are subtracting from lower. This one is a lower value. Okay, here 20 is a lower value. Here 30 is a lower value. Okay. So from class interval values, in that from the lower class interval values, in all intervals we are subtracting minus 0.5 and in upper side we are adding 0.5. This is the rule. Lower side means 10. So in 10 we have to subtract minus 0.5. Then in 19 we have to add 0.5. Similarly, in 20 we have to subtract 0.5. in 29 we have to add 0.5. Okay, so take a class interval. In that, in lower value subtract the 0.5, in upper value add the 0.5. Okay, so take the first interval. I'm taking this first interval. So from first interval I'm subtracting 0.5 from 10, so I will get 9.5. Then I will add 0.5 in 19, so I will get 19.5. Then I will take the second interval, so I will subtract 20 and subtract 0.5 from 20, so I will get 19.5. Then I will add 0.5 in 29, so it will be 29.5. Then third interval I will subtract 0.5 from 30, so it will be 29.5. Then I will add 0.5 in 39, so it will be a 39.5. Then I will take the next interval and subtract 0.5 from 40, so it will be a 39.5. Then I will add 0.5 in 49, so it will be a 49.5. Then next interval will subtract 0.5 from 50, so it will be a 49.5. Then I will add 0.5 in 59, so it will be a 59.5. Similarly 60 to 69, so I will subtract 0.5 from 16, so I will get 59.5. Then I will add 0.5 in 69, so it will be a 69.5. And last will subtract 0.5 from 70, so I will get 69.5, and add 0.5 in 79, so it will be a 79.5. Okay, now after making it continuous, I'm not interested in frequency. Okay, for range frequency is useless, so I'm not interested in frequency. I'm only interested in class intervals. Okay, so just check the class intervals. If class intervals are continuous, then we can directly find the range and coefficient of range. But if the class intervals are discrete like this, okay, 19, then it starts from 20, 29, then it starts from 30. So if it is like this, then first step is we have to make it continuous. Okay, then how we will make it continuous? By subtracting 0.5 from the lower value and adding 0.5 to the upper value, we get this continuous type of class intervals. Okay, so if it is discrete, make it continuous. After making it continuous, again same rule, we have to find the highest value of x. So highest value of x is 79.5. okay, and lowest value of x is 9.5. okay, so highest value of class intervals 79.5 and lowest value of class interval is 9.5. okay, so after getting L and S, largest value is 79.5 and lowest value is 9.5. Now we will calculate the range by using the formula L minus S. So 79.5 minus 9.5, so 70. Then coefficient of range L minus S upon L plus S, so that is equal to 0.79. okay, so with this we can calculate the range and coefficient of range for group continuous data. Only one step is very important while calculating range for group continuous data. Just check the class intervals. It should be inclusive type, it should be continuous. Okay, if it is like exclusive type, means different, okay, there is a break between two interval values, then we have to make it continuous, and then we can find the range and coefficient of range. Now this is the sum. Question is, from the following data, calculate range and coefficient of range, right? So here again frequency is given, number of students means F. So frequency is given, therefore it is a grouped data, right? Now here class interval is given and hence it is a continuous data, right? So group continuous data. Now again see, class intervals are exclusive type, 10 to 19, then 20 to 29, then 30 to 39. So we have to make it inclusive type by subtracting 0.5 from the lower value and adding 0.5 to the upper value. So again I am getting class intervals as 9.5 to 19.5, then 19.5 to 29.5, then 29.5 to 39.5, then 39.5 to 49.5, then 49.5 to 59.5, and 59.5 to 69.5. Okay, after making it inclusive type, then we have to find the largest value of class interval, right? So largest value of class interval is 69.5 and smallest value of class interval is 9.5, and hence range is 69.5 minus 9.5. So range is equal to 60. Coefficient of range is L minus S upon L plus S. So coefficient of range is 0.76. Okay. So this is the method of calculating range. Now class, as I told you, in range there is a no use of frequency. This value is useless, right? So for the previous value, in previous example, see we are having till 70 to 79, right? And here we are having 60 to 69. Okay, suppose there is one more value. Okay, suppose there is one more value, 70 to 79 with frequency 8. Okay, then here we had 69.5 to 79.5, right? And then our largest value will be 79.5, smallest value will be same, right? Range will be 70. Okay, so what I am trying to say that in previous example, previous is an example of age and frequency, right? Then second one is an example of class intervals means marks and number of students. Now suppose if we are having same interval, okay, if we are having same interval, then we get the same range and same coefficient of range, but it is practically not possible. It is not the right method, right? This is not the right method. You are getting my point? We are not using the frequency, but frequency has an impact on the x values, and we are totally neglecting that frequency, and hence range is a not proper measure of dispersion. We can find the range. This is a very basic thing, but it is a not more useful thing. Okay, so for that we will use the further measure of dispersion. So before that, I am giving you some example which you have to solve. Okay, and you have to check your understanding by solving these examples based on range and coefficient of range. So with this I am concluding this video. So thank you students.